Hi guys, I'd like to welcome all of us to my channel of Honest Sciences and Mathematics TV channel. And I'd like to request our members to kindly go to YouTube and search Honest Sciences and Mathematics TV channel, subscribe and engage us in the comment section, and also click that notification bell so that we can be getting various updates on various uploads that we have done in mathematics and sciences. So today we are going to look at one of the applications of revolutions about a specific axis. And this basically is the concept of definite integrals, which we had said, of course, is going to assist us achieve the integrals of various regions that are going to be obtained from the process of revolution. So today we're going to consider revolution along the y-axis, and this is going to give us a figure given in this specific illustration. So therefore I'm going to give this specific figure for a revolution along the y-axis. And this is going to assist us obtain a solid of a revolution that is going to be described as such. So in this specific case, of course, we're going to obtain this volume by using that general illustration for the description of a disk, whereby we had said that we can be able to give the entire volume of a revolution of this particular aspect by considering this small section, whereby a number of them are therefore going to be form a summation of the integral between C and D over this specific region rotated along the y-axis. So therefore we can be able to illustrate this one as an integral from C to D, which is going to be given as the integral from C to D of pi, and then the function for our case is going to be the function with respect to a y-axis, which is going to give us, of course, a radius. So in our case here, we are going to consider our radius to be a point from this y-axis to this specific region. We can be able to give this one in terms of another function with respect to the y-axis given as gy. So therefore, that's going to form our radius. So the product of pi, the square of the radius, and the height, which is going to be given as dy, is going to form what we call the volume of a revolution given as such. So therefore, that's the general way in which we can be able to represent the volume that is going to be obtained from a revolution of this specific region. So I'm going to give a specific example for this so that we can be able to give a description of how we can be able to describe that one. So in this case, of course, it can be either x or y axis, as I had mentioned earlier. So suppose we have a region that is bound by this curve, whereby we have y-x-axis represented as such, and this is the region that I'm illustrating from this, ranging from 0 to 2. So those are the intervals, and this is for the curve of y is equals the value of 2x minus the square of x given as such. So if the region bounded by the graph of y is equals negative 2x minus x, and the x-axis is revolved about the y-axis, so this is going to be revolved about the y-axis as such, and we are requested to find the volume of the resulting solid, and therefore we are going to use this general expression that I've given on my top right, whereby the volume is going to be between the integral 0 to 2 over 2 pi x, and then we are going to have this f of x represented as 2x minus the square of x, and that is going to be represented as dx. So in this specific case, then therefore we are going to have it given as, so this basically is going to form a substitution for this. We just have to do a correction. We have said that if this one is going to be revolved, then therefore the farthest point from this particular axis for negative is going to be -2. So therefore we can be able to do that one an integral by trying to do a substitution for that specific range between -2 and 2 for 4. So this is going to be 0 between 0 and 2, and this 2 is going to cater for that specific volume which has been given twice. So therefore we can be able to have this one given as the integral of this one, the square of this one given as such. So this is going to be the integral between 0 and 2 pi, and then we're going to have this one given as 4x squared, and then this is going to be a negative So we can just do a quick evaluation of this, whereby we're going to have this one given as 4x squared. So this is going to give us a negative 4x to power 3, and then this is going to be plus x to power 4. You can just do an evaluation and confirm that one. In case there's a correction, we can just have it in the comment section. So this is going to be given as such, and therefore we're going to take this 2 pi out of this summation sign, and therefore we're going to have this one given as the integral over 4x squared minus 4x power 3 plus this is going to be x to power 4 dx. Therefore we do an integration over this. This is 2 pi, and then we have 4 over 3 x cubed minus 4 over 4 x to power 4, and then plus x to power 5 over 5 between the range of 0 and 2. And then this is going to be, if we do a substitution for this, we're going to obtain therefore 2 pi into the substitution for 0 for x is going to give us 0, so therefore we're going to use this first one for 2, whereby we're going to have 4 into 2 to the power of 3 is 8 all over 3 minus, so this 4 is going to cancel, x to the power of 4, 2 is going to give us 16, and then the last one plus 2 to the power of 5 is going to give us 32. And from this one we can be able to evaluate those in brackets, whereby we're going to have this one as 32 over 3 2 pi, and then this is going to be plus this is going to be 16. So therefore if we try to look at this one, we can be able to do this one and find a value which is going to give us the value. So this is going to be 53.2 pi and then cubic units. So we can just do a confirmation for this and try to see whether that's a correct figure in our substitution, and then we can give that one in the comment section. So catch us in our other videos whereby we're going to look at various applications of our definite integrals, and this is going to add on this specific concept that we have learned. So that is it for now, guys. Bye. God bless.